Hi, I think you are aware of the fact that the last Sunday your JEE Advanced 2026 was held, and today after 2 days we are going to discuss the solution of JEE Advanced 2026. So we are going to start with paper 1, and in this video we are going to discuss only section 1 and 3 because they are of single calculation type, or only one answer we will get. So we will cover section 1 and 3 in this video. In the next video we are going to discuss section 2 and 4. We'll start. I'm having the question paper in my tab. So let's start with the first question of section 1. That is from the rotational mechanics chapter and as well as the circular motion concept is included. So let's start. Consider a large disk of radius capital R and two smaller disks, each of radius smaller equal to capital R by 50 lying on its circumference as shown in the figure. The smaller disks are initially in contact with each other with the angular separation delta theta between the centers. They are made to roll without slipping in opposite direction with constant angular velocities omega and 2 omega, while the large disk is held stationary. That is why the problem becomes little bit easy. If the large disk is not stationary, that time the problem will be very difficult to calculate. Okay, you have to find out the time tau at which the smaller disks are again in contact is. So let's, and they have given that sin delta theta equal delta theta, you can assume, and you have to ignore gravity. So let's draw the diagram. I am copying the diagram from the question paper. The diagram will be looking like this. The bigger disk of radius capital R and smaller is given R by 50. Your smaller is going to be the radius of the smaller disk of two smaller disks. This is going to be the diagram. The angular separation when they are in contact is going to be delta theta. That means if I join with the center of the bigger disk, I will get the value of angular separation between the two smaller disks. This smaller disk is rotating with 2 omega angular velocity while having pure rolling motion on the circumference of the bigger disk. The second smaller disk is rotating with omega angular velocity with respect to its own center. Please remember, with respect to its own center it is having this kind of angular velocity, right? And this circumference of the bigger disk will be treated as the ground. So they are having initial angular separation delta theta. So they will be meeting again on the circumference only. If they are having pure rolling motion, they will meet again. Let's assume the somewhere here. Let's assume. So when they will again be in contact, that time also the angular separation between them is going to be delta theta only. So ideally, while having pure rolling motion over the circumference of the bigger disk, they are going to cover how much angular distance or combined angular distance. They are going to cover, total angle is 2 pi minus delta theta plus delta theta. That is, they are going to cover or angular distance covered is 2 pi minus 2 delta theta is the angular distance covered. Now see the first, let's make it first smaller disk is the second smaller disk. The first smaller disk is having angular velocity of 2 omega with respect to its own center. So we will treat the circumference as ground. Smaller disk 1, 2 omega. Its center velocity is going to be, for pure rolling motion, if the ground is fixed, the center point velocity is going to be 2 omega r. So in this direction your center point velocity is going to be 2 omega r. For the smaller disk 2, your the velocity of the center is going to be towards left, omega into r. Now this 2 omega is the angular velocity with respect to its own center of the smaller disks. I mean both of the smaller disks. Now it is going to roll. It is going to have one angular velocity, let's say omega 1, with respect to the center of the bigger disk also, because it is covering some angular distance. It must have some angular velocity with respect to the bigger disk center. So what is sigma 1? Sigma 1 is, now see, your center point velocity of the smaller disk 1 is 2 into omega into r. We know the distance between the center, two centers, that is center of the smaller disk and center of the bigger disk. It is going to be r plus r. So if I divide 2 omega r by r plus r, we will be able to find out what is omega 1. That is the angular velocity of the smaller disk 1 with respect to the center of the bigger disk. It is going to be 2 omega r by r plus r. Similarly, you will be able to find out omega 2, that is small omega r by r plus r. And as they are moving in the opposite direction, their relative angular velocity is going to be omega 1 plus omega 2, or big omega 1 plus big omega 2. So with this angular velocity, they are going to cover this much angular distance. So how much time it will take? It will take distance or angular distance by angular velocity, that is 2. And if we simplify it, we will get the answer. Now let's put the value of delta theta from here. So delta theta is very small, so it is given that sine delta theta equal to delta theta only. Now if I make one right angle triangle, but which is having angle here is going to be half of the angular separation between them, that is delta theta by 2, only half angle I am considering. It is going to be height by hypotenuse. Your height is going to be smaller, your hypotenuse is going to be r plus r, delta theta by 2. So if I simplify, I will be able to find out what is the value of that. If I put the value of r by 50, let's make it r by 50, here it is r plus r by 50, it is becoming 1 by 51, that is the value of delta theta by 2. So delta theta value is, you can write 2 by 51, that is the delta theta. Now let's put the values, all the values here, let's put that, and your answer will be here only. So sigma 1, so again you have to simplify this, you have to put the value of r to be r by 50, so it is going to be, let's put the values first, 2 omega r by r plus omega r by r plus r. If I simplify, 2 pi minus 4 by 51 by 3 omega, and r by r plus r I can take common. The value of r by r plus r I already found out, that is, this value is 1 by 51. 2 pi minus 4 by 51, 3 omega into this is 1 by 51. So your answer is going to be time taken for those to touch, to be in contact again. It is going to 51 multiplied with 2 omega minus 4 by 51. Here outside your denominator, it is going to be 3 omega. And let's see which one of the options are matching. It is going to be option number C. It is matching with option number C. So answer is going to be C. I think most of the students who appeared seriously in JEE Advanced, they solved this particular question. So let's proceed to question number 2. Let's discuss our next problem. It is given that consider a circuit consisting of a capacitor of capacitance C and a coil with n turns per unit length, cross-sectional area S and length D, where D square is very greater than S. There is another coil of length D by 2, cross-sectional area S by 2, and 2 n turns per unit length completely inside the larger coil as shown in the figure. The self-inductance of the larger coil is given as L, neglecting age effects and all the omega resonance frequency of the circuit. You have to find out. Okay, let's solve this. Let's draw the diagram first. I will try to remember the diagram. Yeah, okay. There is one circuit. There is one capacitor. This is the AC source, and this is going to be okay. This is going to be the bigger inductor, exactly like this. The length is given as, I think, D. Length is D, its cross-sectional area is S, and n number of turns per unit length. Now inside the bigger inductor there is one smaller inductor. Its length is E by 2, its cross-sectional area is S by 2, and turns per unit length, that is 2 into n. That is going to be the inductor. Now see, there are ideally two inductors. One is the bigger one, and the second one is smaller one, that is inductor number 2. Inductor number 2 is inside the inductor number 1. Let's find out the self-inductance of the bigger one. Self-inductance of the bigger one is given as L. Then what is the value of L? Now if let's say I current is passing through the bigger inductor. The magnetic field inside the big conductor is going to be mu naught into N into I. N is the number of turns per unit length. Then self-magnetic flux is going to be phi, that is equal to B into total area. Your B is already I know, mu naught into N into I. Your area of the bigger one, total area of the bigger one is number of turns per unit length is N. So total number of turns in total D length is going to be D into N. So per turn there is S area. So your magnetic flux or self-magnetic flux is going to be this one, that is mu naught N square D S I, that is equal to phi. So this L is ideally this one, that is L is from here I can write down the value of L, that is mu naught N square D into S. Now this is L1, that is equal to L. So for the smaller inductor, what is the self-inductance? Mu naught. In this case, your number of turns per unit length is 2n square multiplied with the distance or the length multiplied with the cross-sectional area s by 2. So it is going to be mu naught n square ds. So for the smaller inductor also, your self-inductance is becoming L, that is equal to L1. First of all, I have to find out L1, L2, then I have to find out mutual inductance also, because they are interacting. This coil is inside the bigger coil, so they are interacting, mutual interaction is there. So whenever magnetic flux is changing in the first coil, it is going to change or induce EMF in the second coil. That means they are interacting with each other with mutual inductance. Now see, you know that mutual inductance phi of 1 for the first one due to your second coil is going to be equal to phi or the magnetic flux of 2 due to 1, same, and that is equal to m. Can you find out that? How to find out that? Now let's calculate magnetic flux on coil number 2 due to coil number 1. So magnetic flux in coil number 2 due to coil number 1. That means magnetic field I have to find out for coil number 1, and I have to multiply with the cross sectional area or total cross sectional area of the coil number 2, B1, A2. So B1 is already I know, at any point of time if current is I, and I can write mu naught into N into I is your magnetic field. So this magnetic field is generated here. Some of the magnetic field lines are getting intercepted by the second coil, and I have to multiply with area of the second coil. Second coil area, total area of is going to be per unit length, your number of turn is 2n. So per d by 2 length, your turn is becoming, number of turns are becoming 2n into d by 2. That I have to multiply with the cross sectional area on the smaller coil. That is going to be mu naught n square ds by 2. It is ideally becoming mu naught n square ds by 2, that is becoming L by 2. Now everything we have found out. M we have found out, L1, L2 we have found out. Now see, the first approach. What is the first approach? First approach is we are going to consider that this is one parallel connection but opposite polarity. Why it is that? Because whenever, let's say the bigger coil will try to change the magnetic flux in this direction or in the upward direction, this inside magnetic coil will try to oppose that. And that means they both will have the opposite polarity. Though they are not connected, just like parallel, they are not connected parallelly, just like this. They are not connected parallelly. It is not the circuit. But we can assume it is to be a parallel connection having opposite polarity. In that case, because whatever EMF is going to be induced for the first coil, the same EMF is going to induce for the second coil but in opposite polarity. Now, equivalent inductance for the case of parallel connection with opposite polarity is L1 L2 minus m square by L1 plus L2 minus m, sorry 2m. That is the formula of parallel inductors connected with opposite polarity. Now L1 L2 we know the value is L. M value is, by the way, L by 2 square, and L1 plus L2 is 2L minus 2 into L by 2. It is becoming 3L by 4. So L equivalent is becoming 3L by 4. Now your equivalent circuit or equivalent LC circuit is becoming this one. Is 3L by 4. This is C. So your angular frequency is going to be, or resonant angular frequency is going to be 1 by root over of LC, and the value is L here is L equivalent, by the way. If I put the value of L equivalent to be 3L by 4 into C, that is going to be 2 by root 3 in L into C. So which option is matching? Let's check it. It is matching with option number C. But see, this is the first approach. You are assuming this is parallel connection with opposite polarity. There is another approach. How to find out that we will see. There is another approach. Without remembering the formula of parallel connection, you can find out the value of the L equivalent. Ideally, you have to find out the L equivalent, and once you find out the L equivalent, you know that your angular frequency or the resonant angular frequency is 1 by root over of L equivalent into C. With that you can find out. But let's find out L equivalent with another approach, second approach. Okay. Let's assume that in the outer coil your current is I1 and it is changing with the rate of dI1 dt. For the second coil, let's assume that your current at any point of time is I2 and it is changing dI2 dt. Because whenever there is a current change in the outer coil, it is going to induce the current change in the second coil also, or the inner coil also. That's how they are interacting mutually. Now, let's write down for this case, for the first coil, what is going to be the equation? Let's say at any point of time, the potential difference across the outer inductor is going to be V. So if I write down KVL, that is going to be L di1 dt, L dy1 dt, or L1 di1 dt. At the same time, it is getting EMF generated due to the mutual interaction of the second coil also. That we will write M di2 by dt. Now for the second coil, there is no potential difference because there is no potential difference source is attached here. So it is going to be L2 di2 dt plus mutual interaction. Mutual inductance is linked with current in the outer side, that is going to be 0. Now, if you solve these two equations, if you replace, let's say, di2 dt with di1 dt, you can write di2 by dt, that is going to be equal to minus of m by L2 di1 dt, and if you put that in the first equation, you will get that V equal to L1 di1 dt plus m into minus m by L2 di1 dt. You are getting di1 by dt, if you take common, you are getting L1 minus m square by L2, and this is going to be your equivalent inductance in the circuit. L1 minus m square by L2. Let's calculate that. L1 is L, m we already found it is L by 2, so L square by 4, by L2 is also L. It is becoming L square minus L square by 4 by L, that is becoming 3L by 4. So ultimately we are getting the same equivalent inductance from the circuit, and after that the process is same. You can continue with this process. 1 by root over of L equivalent into C is going to be your angular frequency or the resonant angular frequency. Okay. Let's proceed to our next question. Your next question is also having rotational mechanics concept. Let's start. A solid cylinder of radius capital R rolls without slipping with a center of mass speed V0 equal to root over of GR by 3 on a horizontal surface with a vertical edge. Let's draw that. Third problem, this is going to be your one surface with edge. It is rolling here is having r as radius, and the center of mass velocity is v0 is given as root over of gr by 3. Okay. At the moment when the cylinder loses contact with the surface due to the rotation around the corner, the speed of the center of mass you have to find out. That means this will ultimately come to the edge and it will have a rotation with respect to the edge point, this corner point. The moment it will lose the contact with the edge, you have to find out what is going to be the center of mass velocity of the disc. This is very conceptual. I mean, I found the problem is very conceptual, and you have to be aware of the event that is happening while it loses the contact with the corner point. You have to be very aware of the event that is happening here. Let's see. Let's say v0 equal to root gr by 3. So first we'll find out. We'll try to use watt per energy concept. So initial energy, total energy is going to be total initial energy is going to be rotational energy as well as rotational kinetic energy as well as translational kinetic energy, EKE. Your rotational kinetic energy is half I into omega square plus kinetic energy is half into m into v square. Your omega is purely rolling, is pure rolling. So your omega will be v0 by r. That value is going to be 1 by r gr by 3. That is pretty straightforward. For the case of cylinder, your value of I is mr square by 2. So just put the values mr square by 2. Omega square is 1 by r square gr by 3 plus half m gr by 3. So it is becoming capital M. Then becoming r square cancelling out mg r by 3 to 6 12 mgr by 12 plus mgr by 6. So it is becoming 2 3 mgr by 4. So your initial kinetic energy we have already found out. It was required to find out initial kinetic energy, total energy initial found out. Now let's go to the event. What is happening here? Event. So at the corner, we'll just try to draw the corner one. This is the corner. Okay. Now see, the moment this disc or this cylinder will lose the contact with the corner point, it is going to have pure rotational motion with respect to the corner point. The entire body will rotate with respect to this particular corner point only. Let's assume that at that point your angular velocity is omega or capital omega, and at that point of time, if I join with the center, it is making theta angle with the vertical. Let's assume. Okay. Please understand, this entire body is having pure rotational motion with respect to the corner point. That is what is happening here while losing the contact. Okay. Now let's assume that this is having center of mass velocity is Vc. This center will experience one outward centrifugal force, that is capital M Vc square by r, and this will get one normal reaction from here. That means this entire thing will get a normal reaction from here. And due to the normal reaction, whenever the normal reaction is going to be 0, n, that time it will have or it will lose the contact with the corner point. And what are the other force? Mg is acting downward, right? The thing is, Mg is having this component, or in this direction it is having component. This is theta, means this is also theta. So mg cos theta, whenever mg cos theta is exactly balancing with mvc square by r, that time the n, if it is 0, that time you can write it will lose the contact with the corner point, mg cos theta. That is the condition, or that is the angular displacement or the angular distance with the vertical. That time it is losing the contact with the corner point. Now we can find out Vc, that is equal to root over of gr cos theta. But we do not know yet what is the value of cos theta. We do not know yet. Now if I somehow find out the value of cos theta, I can just put here and find out what is the velocity of the center of mass or velocity of the center of the disk while losing the contact with the corner point. Now for that is why we have found out the initial kinetic energy. So in that case, so in this position, if it is state 2, this is state 1, normal state, whenever it was rolling completely, and this is the moment of losing contact, this is 2. If I find out the total energy at 2, this particular point, if I equate them, I will be able to find out, or there is a chance of finding out the value of cos theta. I can put the value of cos theta here. This is going to be our answer. Now see, this is your total energy in. Now your initial total energy in plus the moment, this is losing the contact, your gravity or mg amount of force has done some work on this particular cylinder. Let's say that amount of work is delta W, and total work done plus the initial kinetic energy, total energy, is going to be your final total energy, that is half of I into omega square. If it has descended, now see what is the height of descent from here. Initially it has the center of mass was at height r. Now its height from the surface is reduced to r cos theta. So what is the height it has reduced, or what is the height it descended? mgr by 4 will write down, plus delta W is going to be mg multiplied with r minus r cos theta, is going to be the extra work done on the cylindrical object, and the final energy is going to be half of I into omega square. But what is the value of I? So I is right now, you calculate the value of I from this point. This is your center of rotation. Now your I is going to be mr square by 2 shifted by r addition, that is 3 by 2 mr square. So mr square by 2 plus mr square is 3 mr square by 2, and omega is going to be, now see the entire body is right now rotating purely with respect to the corner point, that is the event it is happening. Now your omega is Vc is due to omega only. So omega multiplied with r is going to be your Vc. Now omega in terms of Vc is going to be Vc by r square. Now we can simplify it. We'll try to okay, let's make it like this: mgr by 4 plus mgr 1 minus cos theta is going to be equal to 3 by 4 mr square Vc square by r square. Now if I put the value of Vc here, I'll be able to mr square, Vc value I have already found, as root over of gr cos theta, so it is gr cos theta by r square will cancel, mgr will cancel out, each side I'll cancel out. So the equation is becoming 1 by 4 plus 1 minus cos theta. If I simplify it, it is going to be 5 by 4 minus cos theta, that is equal to this side 3 by 4 cos theta. Done. Now it is becoming 3 by 4 cos theta plus this side, if I take the cos, then it is becoming 7 by 4 cos theta, that is 5 by 4. So your cos theta value you are getting 5 by 7, that is the value of cos theta. Now as I told, you can find out the value of cos theta and put it here to find out the central velocity. The central velocity is going to be the over of gr into 5 by 7, that is 5 gr by 7 is your answer, which is matching with, I think, let me check the option, it is matching with option number B. So option number B is your correct answer, root 5 gr by 7. Now let's proceed to your next question. Your next question is very simple from geometrical optics. I have seen it's very simple. I do not know why they have asked it, but just for maybe students to score, they have asked this problem. I am just starting to solve the problem. So let's start. A double convex lens made of glass of refractive index 1.5 and radius of curvature of the curved surfaces 20 cm each, immersed in a liquid of refractive index NL. The correct plot showing the variation of power in the units of diopter as a function of N suffix L is. You have to find out the power versus NL graph. So one lens is immersed in a liquid having, this lens is having refractive index 1.5, it is immersed in a liquid having refractive index N suffix L. Now from the lens formula you know that 1 by F is going to be 1 by R1 plus 1 by R2. I am considering 1 by R1 plus 1 by R2 because I am taking care of the sign also here, multiplied with mu relative minus 1. Let's put the value of R1 R2. It is 20 cm each. So but in the okay, in data I have to find out. In the data means I have to put the value of R to be in meter. That is, let's put 0.2 here, also 0.2. Mu R is relative refractive index of the lens with respect to the outside medium, that is 1.5 by NL minus 1. This one is going to be 2 by 0.0, that is 10 NL minus 1, and power is this one. Because I am putting the value in meter only, that means this is giving us the unit of power in diopter only. Let's find out from the graphs. Okay, in the first graph, let's check the, I think, see the first graph. Okay, whenever the value of NL is equal to 1, because each and every graph is starting from NL equal to 1. If I put the value of NL equal to 1, your power is becoming NL equal to 1 is 5 diopter. So the graph should start from 5. Each and every graph is starting from 5 only. The first and second graph is starting from 5 only, by the way. Whenever your NL is 1.5, that means the outside medium is having the same refractive index of the lens, that time your power will be 0. This is becoming 0. It will cross, and whenever your NL value will exceed your lens refractive index, that time your power will be negative. So it is very evident from the graphs that the first graph is showing the nature, because this function cannot be a straight line. So between A and B, if you have to choose A. That is the only thing, because that is option A is the correct option. It cannot be a straight line because P is not proportional to NL or N suffix L, by the way, and it is not downward also. So it's kind of, the graph will be kind of a curve like this. Okay, this is the graph is going to be done. I think section 1 we have finished. We'll proceed to section 3. After this we will proceed to section 3. So the numerical values, there are 4 questions. So let's proceed to section 3. That is question number 9, by the way. I'm writing question number 9, section 3. The question is given from SHM along with some fluid mechanics concept is required because we are having SHM inside one fluid or one liquid. It is given that a tank contains 2 immiscible liquid of density 6 rho and 2 rho. The higher density liquid is filled up to height L by 2 from the bottom, and a thin rod of density rho and length capital L is fully immersed and hinged at the bottom so that it can oscillate freely as shown in the figure. If the rod is slightly disturbed from its equilibrium, time period of small oscillation is going to be 2 pi by n root over of L by G. I have to find out the value of n. So it is not integer type, it is having numerical type. That means n, there is no obligation that n should be an integer, but n can be any numerical value. N can have any numerical value. Let's just draw the diagram. So this is your beaker, which is filled with two separate liquids. The bottom one is having 6 row of density. The top liquid is having density of 2 rho, and inside that one rod is there, which is hinged at the bottom. That means it can rotate freely with respect to the bottom point. That is the only thing. And the length of the rod is given as L, density of the rod is given as rho, and we have to assume the cross section area of the rod. Let's assume it as A. And this is the equilibrium position, because normally your buoyancy force that is acting on the rod will be vertically upward, so this is the equilibrium position. Now for SHM, from your equilibrium position, if you disturb the state, it is going to, let's say you have displaced it, you have given some angular displacement, let's say to the rod, and the rod is looking like this after small displacement, angular displacement. Now see, this is not very stable position. Top half of the rod will get some buoyancy force due to the density difference between the liquid and the rod material. Similarly, the bottom half of the rod is also going to get one buoyancy force. And now see, with respect to the pivot point, these two forces are creating one restoring torque, and due to the torque only, this will oscillate to and fro like this. That is the concept of the problem. Now let's solve this. Let's assume that this is the disturbed position of the rod after small angular displacement, let's say given, that is theta. Small angular displacement theta is given. Theta is very small, by the way. But see, your top half is with different liquid having 2 rho density. The bottom half is having different liquid having 6 rho density. Now see, for the top half, what is your buoyancy force acting in the upward direction? Buoyancy force will always act in the upward direction. Your buoyancy force is going to be rho into L by 2 multiplied with A into G, rho into V into G. But your density of the liquid is 2 rho here in the upper half. That is why 2 rho into volume is L by 2 into A, because we are considering L by 2 length only. This into G. And your downward force also acting, that is the weight of the rod, that is weight of the rod is rho into L by 2 into A into G. The net force in the upward direction, let's say F1 is going to be upward force minus downward force, that is, if you subtract this, you will get rho L by 2 into A into G. Similarly, the bottom half will also get one upward force and weight is acting downward. So net force in the upward direction is, you can directly write, that is the density difference, that is 6 rho minus rho into V into G. V is the only submerged portion in that liquid, that is L by 2 into A into G. That is the net force acting in the upward direction. So these two forces are acting from different points. So what is the net torque due to the second force, net force F2? F2 multiplied with this distance, that is, this is L by 4, by the way, because your this net force will act from the center of mass of that particular portion, that is going to be your distance or perpendicular distance from the vertical position, that is going to be generate one torque M2, that is F2 into L by 4 into sine theta. This is theta, that means this one is becoming L by 4 sine theta. But you can write sine theta as theta because theta is very small. Now see, your moment 2 or the moment generated due to the force F2 is F2 multiplied with L by 4 multiplied with theta. So F2, if I simplify, I am getting 5 rho L A by 2G. It is becoming 5 rho L square A G theta by 8. Similarly, due to the first force, F1 force, your F1 force is acting at L by 2 plus L by 4, that is 3 L by 4 distance. So moment generated, or the restoring moment generated due to the force 1 is going to be rho L by 2 AG, F1 multiplied with 3L by 4, but this distance is 3L by 4 sine theta, so sine theta I can write theta. Right. So if I multiply, I will get rho A L square G theta by, or multiplied with 3 by 8. So total restoring torque is becoming tau equal to M1 plus M2, because these two restoring torque is acting in the same direction, that is anti-clockwise. This will try to restore the equilibrium position. That is why it is called restoring torque. Rho A L square G theta plus 5 by 8 rho A L square G theta. If I add them, I will get rho A L square G theta only, that is equal to tau. I have to put minus sign because it is restoring torque in nature. Now your torque is I into alpha. What is the value of I? the entire rod is rotating with respect to the pivot point at one extreme end. So your I is going to be 1/3 m into L square. What is the value of m in terms of its density? Rho into A into L into L square, that is, you can write rho A L cube alpha equal to minus rho A L square g theta. So I'm getting, if I cancel this, rho A I'll cancel out. So I'll get alpha value is 3g theta by L. So from here you know that your omega value or the angular velocity is 3g by L. So your time period is 2 pi by omega. 2 pi by omega is 3g by L. That means if you put it, it is going to be 3g. So now see, you are getting 2 pi by root 3 root L by g. That is your time period. Now in your question it is given that 2 pi by n into root over of L by g to find out the value of n. Now in this case your n value is root 3, that is 1.73. That is going to be your answer. Numerical time. Done. Okay, let's proceed to question number 10 from numerical type, section 3. As shown in the figure, 5 Carnot engines, each with efficiency eta and same number of cycles per unit time, are operating between 6 heat reservoirs. The amount of heat released per cycle by one engine is completely absorbed by the next engine. Consider Q naught to be the amount of the heat absorbed per cycle by the first engine, and W is the amount of total work done by all the engines per cycle. The net efficiency of the system is found to be eta net is W by Q naught, that is 211 by 243. The value of eta you have to find out. Now in total there are how many Carnot engines? In between 6 reservoirs, so only 5 Carnot engine can be placed. Okay, let's make it like this. This is our first reservoir, heat reservoir, first engine, again second engine, third, fourth, fifth, and this is the last heat reservoir where heat is getting rejected by the 5th Carnot engine. So heat absorbed from the first Carnot engine is Q naught. It is giving W amount of work, W1 amount of work. Second one is giving W2 amount of work. Whatever it is rejected by the first one is totally absorbed by the second one. So Q1, here reaction is Q2. Now the third Carnot engine is getting Q2 heat. It is rejecting Q3 amount of heat. It is rejecting Q4 amount of heat. At the end, it is rejecting Q5 amount of heat. Each Carnot engine, as they are getting different amount of heat input, their work output will also be different. Okay. Now work output for the first Carnot engine is going to be, but one thing is common between all of them, that their efficiency is eta. Now for the first Carnot engine, what I can write, W1 value, W1 is total heat input by minus heat rejected, that is Q naught minus Q1. So W2 is going to be Q1 minus Q2, that is heat input for that engine minus heat rejected. W3 is going to be Q2 minus Q3, W4 is going to be Q3 minus Q4, and W5 is going to be Q4 minus Q5. Now your net work done by all of them combined is going to be W, that is W1 plus W2 plus W3. You have to sum all of them. Now the thing is, your net work done by all of the engines is going to be, this one will cancel out, cancel out, cancel out, is going to be Q naught minus Q5. Done. Now, in your problem it is given that total work done by total heat input is Q naught. It is going to be your efficiency, that is 211 by, I think 243 is given. Now your W, I have already found out, that is Q naught minus Q5. That means Q naught minus Q5 by Q naught is your 211 by 243. Now this one, if I simplify, it is becoming 1 minus Q5 by Q naught. It is going to be 211 by 243. Now Q5 by Q naught, it is 1 minus 211 by 243 is 1 minus 32 by 243. Now what is the value of Q5? Now see, For one engine, I can write that 1 minus, for the first engine I am writing, for 1 minus heat rejected by heat input is eta. So Q1 I can write 1 minus eta Q0. Similarly, for the second one I can write Q2. Second one means heat rejected is going to be 1 minus eta into Q1, its own heat input Q1, but Q1 is already expressed as 1 minus eta into Q0, so it is becoming 1 minus eta square into Q0. Q2 is 1 minus eta square into Q0. Now see, you are able to see what is similarity. Q1 power of 1 minus eta was 1. Q2 power of 1 minus eta is 2. For Q5, if I find out value of Q5, your Q5 will be 1 minus eta to the power 5 into Q0. My Q0 is 32 by 243. Now you are getting, this is cancelling out, 1 minus eta to the power 5 is 2 by, this is 3 to the power 5. So 1 minus eta is becoming 2 by 3. Your eta value is 1 by 3, or that is 0.33. That is your answer of the question number 10. Answer is 0.33. This is very good question from thermodynamics. I mean, this all of these steps you need to understand in order to solve this problem. I think 2 years back also one good question was given from thermodynamics, Carnot cycle, and series of heat engines are given. So this is also kind of the previous problem I have seen, but this is having completely different approach. So this is very good problem by the way. Let's proceed to question number 11 from section 3. As shown in the figure, by the way, this question is also from thermodynamics. So this is a very good question. I have found it very conceptual. Okay, let's start. As shown in the figure, an insulated container is fitted with a thermally conducting but immovable partition P1 and freely movable but thermally insulated piston P2. The partition P1 with thermal conductivity K, cross-sectional area A and width X divides the container into two sections S1 and S2, each containing 1 mole of monoatomic gas. The piston P2 moves freely such that the gas in S2 is always at the atmospheric pressure. Please try to understand from this statement. So whatever process, so whenever there is pressure difference between S2 and outside, it will move. It will try to keep the constant pressure. So whatever process is happening inside S2, that part is constant pressure process. But P1 partition is sealed. That means whatever gas or it is there inside S1 portion, it is having constant volume. So as P1 is fixed, it cannot move. So whatever process temperature change is happening in S1, that is going to be constant volume process. Okay, let's proceed. The piston Me2, okay. Initially the temperature difference between the temperature S1 and S2 is delta T naught. The time it takes for the temperature difference to become delta T naught by 2 is Nx into R by K into A, where R is the universal gas constant. The value of N you have to find out. Let's draw the diagram. Question number 11. This is your diagram. This is P1, partition P1, which is fixed partition, it cannot move, and there is another movable partition P2, that is this one. So both of these portions are having 1 mole of monoatomic gas. Monoatomic gas, that means gamma we have to use. Let's write the value of gamma for monoatomic gas is 5 by 3. Okay. This can move freely here and there. This partition, the fixed partition, that is having thermal conductivity K, cross-sectional area A, and thickness X. Now, between S1 and S2 temperature difference initially, that means whenever T equal to 0, the temperature difference between them is delta T naught. You have to find out the time taken when the temperature difference will become delta T naught by half. Now, this is not a source and this is also not a sink. Let's assume that this is having temperature T1 at any point of time, because why I am telling it is not a source, because whatever heat will be transferred via this partition T1, that is going to decrease the temperature of the S1 also, and whatever heat is passing via this partition to S2, that is going to increase the temperature of S2 also. So there are two variables by the way. If one is sink or a source, that time whatever heat it can transfer, the temperature of heat or temperature of heat sink and heat source can never change, but this is not the case, this is the real case. Let's assume that at any point of time your temperature for the partition, temperature of the S1 is T1, for the second S2 the temperature is T2. So temperature difference T1 minus T2 is delta T at any point of time, which is also a function of time, because the temperature difference is increasing or decreasing with time, right? It is decreasing with time in this case. It is decreasing with time because as there is no heat source, by the way. Now see T1. Let's assume that in small time dt, because T1 is a variable quantity, whatever heat is getting transferred from here to here, it is going to reduce the temperature of the S1 also. Now in time dt, let's assume that your temperature change is dT1. Heat is going to S2, heat temperature change is dT2. But this temperature change, how much heat needs to be transferred? Q, because this is going through constant volume process. This is going through constant pressure process. If the heat comes here, we will try to move the piston towards right. So if initially T1 is greater than T2, we will assume that Q is going to be Cv dT1 by dt, only 1 mole of gas is there. So whatever heat is transferring, or heat transfer rate by the way, sorry, Q dot is Cv dT1 by dt. That is going to be equal to the same amount of heat is going to get transferred to S2. That is Cp dT2 by dt. That is very important. Now we got, initially we had two variables T1, T2. Now we got at least one relation between these two variable rate of change. Now what is the value of Q dot by the way? Your Q dot value is rate of change of the heat transfer from S1 to S2. Your Q dot is thermal conductivity multiplied with the surface area multiplied with temperature difference at that instant T1 minus T2 by X. That is going to be the rate of heat transfer. If T1 is temperature of S1, this is decreasing temperature because it is losing heat. So I have to put one minus sign here. I am writing this one equal to this one equal to this one, but if I simplify it, I will get okay. I'll try to find out two equations as of now. So minus Cv, first I'll write down dt1 by dt is equal to Ka by x T1 minus T2, and I can simplify dt1 by dt as Ka by x T1 minus T2. Okay. Minus I'll keep it here. Sorry, minus I'll keep it here. Again I can write dt2 by dt as Ka by x. Sorry, 1 by Cv was there. Here 1 by Cp will be there. T1 minus T2. If I simplify this equation, dt2 by dt is Ka by Cpx into T1 minus T2. Now see what I am getting. dt1 by dt, 1 by Cv Ka by x, T1 minus T2, dt2 by dt, this one. So how to find out this variable, this T1 minus T2 from these two equations? Now see, if I add them, I am getting dt T2 minus T1 is equal to 1 by Cp plus 1 by Cv Ka by x T1 minus T2. This T2 minus T1 I can write delta T, or T1 minus T2 I can write delta T. So the T2 minus T1 is going to be minus delta T. So I am writing this minus sign is indicating that delta T, or the temperature difference between them, is decreasing with time. That is the only thing. There is nothing else. So Cp I will write down in terms of R. Your Cp is gamma by gamma minus 1 into r. Your gamma is 5 by 3, so it is becoming 5 by 2r. The CV is 3 by 2r, by the way. Just put the values here. 5 by 2r, so 1 by 5, 2 by 5 r plus 2 by 3r Ka by x T1 minus T2. I will write delta T. Now see, I got my differential equation, so I will solve it here. So d delta T by delta T is equal to 2 by 5r plus 2 by 3r. If I simplify it, 6 plus 10, 16 by 15, 1 by r Ka by x dt. Let's integrate it. This is constant term. Initial temperature difference was delta T naught. Final temperature difference is delta T naught by 2. It is decreasing in nature. So this integration is ln delta T along with the limit delta T naught from delta T. Minus sign is there in front. And this one, if you integrate from 0 to T, 16 by 15, 1 by r K by x T. So if you put the limit, it will become, minus sign will be omitted, it will become ln 2 is equal to 16 by 15, 1 by r K by x T. So T you can find out. The time taken to reduce the temperature difference from delta T naught to delta T naught by 2 is 15 ln 2 by 16 into xr by k into a. That is going to be your answer. But ln 2 value is given as 0.7. I will just put the value to be 0.7. So 15 into 0.7 by 16 is going to be your answer. Let's calculate the value using calculator. I can use the calculator, but you cannot use the calculator. You have to do it by your hand. It's 0.656. The value of this term is going to be your 0.656, and that is going to be your answer of this numerical type question, question number 11. 0.656 is the answer. 0.656. Let's proceed to your next question, and this is going to be the last question in section 3, question number 12. Let's start. After wiping the board, we'll start. Okay. So next question is from magnetic field. A hollow right circular cone of base capital R and height h with its tip at the origin is rotating about z-axis with an angular velocity omega as shown in the figure. The cone carries a total charge q uniformly distributed on the curved surface. The magnitude of the magnetic field at a point 0, 0, z, where z is very, very higher compared to r and h both, is this term is given, and to find out the value of n. Let's draw the diagram. This is going to be your cone. Tip of the cone is fixed at origin. This upward axis is your z axis. Please observe that in your question the axis given it is wrong. This is z is okay, but this one, if this is z, then this is x, this should be y. Okay, because I cross j should be equal to k cap. It is given wrong in your diagram by the way, but that is not going to alter the result of what we are going to get. Plus q charge is distributed over the surface or the curved surface of the cone. Now what is the value of the surface charge density? Q by pi into r into L, where L is the slant length of this cone. That is L. Okay. This height is h. This radius is given as r. Now we'll assume the angle or half angle of the cone is theta. We'll assume that. Then in that case, your slant length L, this length L. What is that? L I can express in terms of H and R both. We'll do that later point of time. As of now, this is going to be a sigma, so we'll work with sigma only. Now see, you have to find out magnetic field at a point which is very far away from the origin, and the distance of the point is also very high compared to the dimensions of the cone. Now let's see that this entire cone is made up of many circular rings having varying radius. So if I take one circular ring here, differential thickness circular ring, if I take here, it is having less radius compared to this circular ring which I will assume here, right? And you have to find out, due to one ring, you have to find out what is the magnetic field at very far away from the ring center. Now, what is the result of this one? If this is one, let's say one ring having radius, let's say small r, at distance x from the center, your magnetic field is going to be towards x-axis or towards right, and if your current flowing is I, your value of the magnetic field is going to be at distance x mu naught by 4 pi, there is a constant by the way, 2 pi into r square by r square plus x square to the power 3 by 2 multiplied with I, that is going to be your magnetic field at distance x from the ring, which is carrying I current by the way. It's a current gets carried with I. Now if x, or the distance from the center of the ring, is very very higher compared to the dimension of the ring, that is smaller, it will be smaller by the way, sorry for that, smaller, okay. Then you can ignore smaller with respect to x. Then your value of the magnetic field is going to be mu naught by 4 pi 2 pi r square. If we ignore this term compared to this term, it is going to be x cube into I. So here the same thing is there, but with varying radius, which is varying, the radius of the rings are varying from 0 to capital R. So I have basically, if I assume one ring at distance, let's say at distance p, if I assume one ring having thickness dp is along the z axis, dp is the thickness of the ring. Now r is any arbitrary radius of the ring. Now what is going to be the surface area of the ring? Now see, if I zoom it, the entire thing, if I zoom it, you will be able to observe that your ring is going to have this kind of slant surface, right? Because it is taken on a cone, it is going to have one slant surface like this, by the way, sorry, okay, like this slant surface, right? Now what is the area of the ring? Your ring is going to have this kind of circular shape, right? Your ring, what is the radius? Radius is r. So your perimeter is 2 pi into r multiplied with the thickness. But you have taken dp along z axis. This is theta. So your this slant thickness is going to be dp by cos theta, right? That is your du, small area of the ring. How much charge it contains? It contains, per unit area your charge is sigma, it contains sigma into d amount of charge, that is dq multiplied with sigma. Now these charges are rotating. So what is the current generated due to this charge rotation? So current generated is I is going to be dq multiplied with the frequency of the cone rotation. Your cone is rotating like this, omega, right? So frequency is omega by 2 pi. So your current generated due to the rotation only is going to be 2 pi r dp sigma by cos theta multiplied with omega by 2 pi. To simplify, 2 pi will cancel out. It is just going to be r dp sigma omega by cos theta. That is your r. And due to this point, or due to this ring, your magnetic field is going to be at z distance. The magnetic field is going to be mu naught by 4 pi 2 pi into I, or 2 pi r square will put, multiplied with I. Instead of I will put this one, r dp omega by cos theta divided by distance from the center of the ring is z in this case. So we are finding out at this point, so z cube. Done. Now we are having, now see if I simplify it, this is dp, this is r. If I simplify it, it is becoming mu naught by 4 pi 2 pi by z cube. All constant term will keep here to the left hand side. For one cone, sigma is constant, omega is constant, cos theta is also constant. So what is variable? R cube dp. Entire part is variable part. Because r is varying, p is also varying. I am varying p from 0 to h, small h. So r is varying from 0 to capital R. We have to express one variable in terms of other variable. Now you know that r by h, so the ratio of radius by the height of the cone, is going to be same for this ring also. Radius by distance from the origin of the cone, or origin of the circle we are assuming here. Smaller by p. Smaller by p. Which one to replace? I can replace p. P is h by r into smaller. So dp I can write h by capital R into dr. So if I replace dp here, I'll get h by capital R into dr. Now this is the magnetic field due to one differential ring only. So intermagnetic field is going to be integration. Your variable is r, so I have to vary from 0 to capital R to get the magnetic field at z point. Just simple integration after this. Integration of r cube dr is r to the power 4 by r. So entire term will remain there. That is, again I am writing mu naught by 4 pi 2 pi sigma omega by z cube cos theta h by capital R. This one will become r to the power 4 by 4. If I put the limit, it will become r to the power 4 by 4. Done. Now r is there, r will cancel out, it will become r cube. Now your sigma is not given to us. Sigma I have to put from q by pi r l. Now see, your L is slant height is h by cos theta. So if I draw one triangle like this, this is h, this is slant height L, this is r, this is theta. Then L I can write h by cos theta, or L cos theta is equal to h. So h is L is equal to h by cos theta. So here I can write sigma value. I have to put, that's it. After this only sigma value I have to put pi r h by cos theta. Then going to be the value of sigma. Let's put that. Let's write the entire expression again. Mu naught by 4 pi 2 pi sigma omega by z cube. Sigma I will not write. Omega h by cos theta multiplied with q by pi r h by cos theta multiplied with r cube by 4. Now see, h by cos theta and h by cos theta is cancelling out. R is becoming r square. Pi is cancelling out. So I am getting mu naught by 4 pi omega cube r square by z cube 2 by 4, that is 0.5. Right. Now in your expression, if I am missing something, let me check it. Q mu naught by 4 pi into n is there, into q r square omega by z cube. So n is this one. So your answer is, n value is 0.5 is your answer of this numerical type question. Done. In the next video we will discuss about section 2 and section 4 all together, and then we will proceed to paper number 2 discussion. Okay. Thank you so much.